We're back at Ellington. We talked earlier about the suit that they're testing this week, a modified what was called ISS suit for the Space Shuttle program that they're now getting ready for the Orion program. And here we have Dustin Gomert here to tell us a little bit about the tests that they're actually doing with that suit. So one of the things involves this seat, right?
That's right. The seat was essentially designed around the suit. We knew that that suit, or a very similar version of that suit, would ultimately be used in Orion. And so we built it around the suit, but what we did additional to that was we built it so that it's adjustable to fit people who range from heights of, say, 4'9" to 6.5 feet tall. And so there's a huge range of adjustability, but by doing that, to make the Orion operable, we had to put everyone so that they fit with basically the same eye point. So when they laid their head in there, they looked at this display no matter what height you are. Well, to do that, we make this seat, the seat pan that you actually sit in, adjustable up and down the axis of their body. Well, the testing we needed to do was show that if we were in orbit and had a depressed cabin contingency, well, the first thing we do is we could get in our suit. And well, obviously that's the most important thing. And then after that, you have to get into the seat to come home, because that's the next most important thing. Well, the suit gets large. It grows quite a bit around you as it inflates. So to ingress this seat in the stiff and large suit, we were testing different options for how to make this seat more maneuverable on orbit. So one of the things that we did was look at different levels of adjustability so that we could translate our bodies into the seat in the pressurized suit and buckle ourselves in for the ride home.
Okay, and I think actually we have some footage of that, those tests taking place on the zero gravity flights that we can show you. But the idea is that there would be 4 of these seats in the Orion, correct?
That's correct. So this would actually be seat 2 of 4, the way it's set up with the displays above it, but you can imagine another seat directly to the left of it and then 2 more positioned directly below it. So there's a grid work of seats that are laid out in the vehicle, one mirroring this one exactly, and then if you can imagine the folks who are below it, their heads are actually below the feet of the pilot commander who are flying above them.
So it's, you know, the Orion's reasonably large for a spacecraft, but still a pretty small space. A lot of difficulty maneuvering around, especially when you've got the bulky suit on.
That's correct. A large spacecraft is still relatively compact compared to what we're used to in the free volume that we have the luxury of being in here. And when the suit inflates around the person, each person, you can imagine, expands to almost double their volume. And so it gets tight very quickly, and so we have to make the most creative use of the space as possible to allow them to ingress the seats for a safe trip home.
And I guess, you know, we can do that a lot here on the ground, but having it in the microgravity simulation is probably a big help.
It's a huge help for us, because one of the things we get in 1G environment, the Earth's gravity environment we're in right now, is we get the effects of stability. We can't spin out of control, we can't lose our grip and fly off. And so in the zero gravity environment, it gives us that real true sense of how the suit will perform when we have that instability and we have to fight to put ourselves in the proper position and lay in the seat to get home.
Okay, and it's probably worthwhile to explain how we simulate that zero gravity. We get the suit and the subjects in an airplane, and they fly in parabolas.
That's correct.
So you get a few seconds of zero gravity floating as you go down, similar to how when you go down a hill on a roller coaster,
correct.
right?
So the plane will pull up at an extreme angle. During that time, the gravity is actually relatively intense. It's about 1.8 times what we're feeling, so you're very heavy during that period. But when it gets to the top, to the apex of that parabola, it dives down, and it dives at such a controlled rate that you fall inside the aircraft at the same rate the aircraft is diving, so you essentially float. Free falling, but you're floating inside the aircraft. It's very similar to what a zero-G environment is.
Okay. Well, and how did the test go this week?
It went very well. We had great luck in proving out the theories that we had on how the person in the suit would ingress the seat, and we learned quite a bit about the mobility of the suit for non-seated but translation type operations for perhaps contingency tasks that we would look at in future scenarios and future missions.
Okay. Will you need to do these again before you're ready to fly, or?
I think from what we learned, we'll probably do a few iterations of design work before we get there, but this gave us the capability to learn what the baseline performance of this suit is, relatively unmodified from its shuttle variant, and also give us an idea of what we need to do to tweak it to make it really perfect for the Orion capsule.
And I know you have some other tests that you'll be performing as the work progresses.
Yeah, that's correct. We started in JSC in Building 9 in the Argos environment, adaptive response gravity offload simulator.
Right.
And so you essentially hang from your belly, very similar to Mission Impossible style.
Okay.
And you can float around in a frictionless environment. But what we don't have is the full degrees of freedom you get in true weightlessness. So we use that as a starting point to get to this environment, and then we used this environment to give us a feel for how realistic that was. That being a much more benign environment, we can test over and over again rapidly.
Right.
And we plan to use that for our development cycle, and then use the flight for some more of our validations of performance in a more high-tech or more realistic environment.
All right. Well, hopefully we'll be seeing more of that coming up.
We hope so.
Thanks so much for talking with
Thank
us,
you.
Dustin. We'll go back now to Mission Control and live coverage of life in space. Thanks.